Hello students, welcome to Sources classes. Today we will be solving the ISI Msqms paper from year 2016. Previously we have solved question number 1 and question number 2 from the same paper. Today we will be solving question number 3 and question number 4 from the same paper. So let's begin with question number 3. In question number 3 it is said that let g of x be equal to e to the power minus x for x greater than 0. So g of x is equal to e to the power minus x for x greater than 0. And let f of x be equal to e to the power minus k when x lies between k minus 1 and k, where x is less than equal to k and k goes from 1 to infinity. So f of x is equal to e to the power minus k when k minus 1 is less than x and x is less than equal to k and k goes from 1 to up till infinity. Then the area of the curve gx minus fx is equal to e minus 1 e to the power minus 1 minus 1 1 minus e to the power minus 1 or e minus 2 by e minus 1. So before that, let us draw the curve gx and fx on the xy axis. So let's begin. This is the y axis and this is the x axis. So gx is equal to e to the power minus x when x is greater than 0. So in that case gx is given by this very function, and it is defined for x greater than 0. So there is a discontinuity at the point x equal to 0. So let us break down this point. It is 1 2 3 4 5 and so on, it will go on. And for drawing f of x we will use a separate ink. Now we know that f of x is equal to e to the power minus k when k minus 1 is less than x and is less than equal to k. So if x is equal to 0.5, then 0.5 is between 0 and 1. In that case f of 0.5 is equal to it takes the greater value of next integer, and in that case f of 0.5 is equal to e to the power minus 1. Similarly f of 0.2 is also equal to e to the power minus 1, and also f of 1 is equal to e to the power minus 1. So basically for any value from 0, f of x is equal to e to the power minus 1 if x lies between 0 and 1, and f of x is equal to e to the minus 2 if x lies between 1 and 2. So the graph will be a stepwise function which will be graphically denoted in the following way. And so on. So this is the function that we are talking about. This is g of x and this is f of x, and graphically it comes down to this format. So now let's continue solving the problem. Let me use more space below to solve the problem. First we'll find out the value of g of x minus f of x dx. Integration goes from k minus 1 to k. For any interval which goes from k minus 1 to k, we'll find out the area under the curve gx minus fx, and this is the formula for the same. And this is equal to, now g of x is equal to e to the power minus x and f of x is equal to e to the power minus k which goes from k minus 1 to k, and this is equal to minus of e to the power minus x minus x e to the power minus k, and it goes from k minus 1 to k, and this is equal to e minus 2 into the e power minus k. But we know that k goes from 1 to infinity, so in that case we have to take the summation of this value over value from k equal to 1 to k equal to infinity to find out the total area under the curve. Therefore total area is equal to summation of e minus 2 into e to the power minus k, where k goes from 1 to infinity. Taking e minus 2 out, it can be written as summation of e to the power minus k, where k goes from 1 to infinity, and the value of this very part is e minus 2 into 1 by e minus 1, and so the value comes as e minus 2 by e minus 1, and this is the option D. Now let's proceed to the next question. So now let's solve question number 4. In question number 4, it is said that the number of ways to fill each of the 4 cells of the table with a distinct natural number such that the sum of the numbers is 10 and the sum of the numbers placed diagonally are equal is 2 factorial into 2 factorial, 4 factorial, 2 into 4 factorial, and 2 into 2 factorial into 2 factorial. So these are the 4 options that we are concerned with here. So it has been said that there is a table which has 4 cells. There are 4 cells here, and each of the cell is filled with a distinct natural number. With a distinct natural number, and the sum of the numbers is equal to 10, and the sum of the numbers, sum of diagonal elements or diagonal numbers, are equal. So we can safely assume that since the sum of the 4 numbers which are distinct is equal to 10, then there is only one possible, then that can only happen if the numbers in consideration are single digit numbers, are single digit natural numbers. So the only possible combination that can occur is if we consider the number 1, 2, 3 and 4, since we know that 1 plus 2 plus 3 plus 4 is equal to 10. So this is the only possible combination that comes into mind. Also, if we take the sum of 1 plus 4 and 2 plus 3, both is equal to 5. So sum, if we take diagonal elements as 1 and 4 or 2 and 3, in that case their sum is equal to 5. So the conditions that the sum of the numbers is equal to 10 and the sum of the diagonal elements are also equal is satisfied. Both the conditions are satisfied. So now we have to find out the number of ways in which 1, 2, 3, 4 can be arranged in this table, which is having 4 cells. Let us use the space below to solve this problem. Firstly, let us draw the table. This is a table which has 4 cells. Now the total combination that is taken into consideration is 1, 2, 3 and 4, and the diagonal combinations are 1 and 4 and 2 and 3. They can interchange the positions, the ordered pair can change their positions, but it is more or less the same process. So for filling up the first cell, we have to choose from any one of these 4 numbers. So there are 4 ways to fill the first cell. After we fill the first cell, the next cell has to take when we take one particular value to fill the first cell, then the next cell cannot be filled by the value, the addition of which leads to the number 5. So suppose if we take the value 1 over here, then the adjacent cells cannot take the value 4, since the sum of the diagonal elements will not be equal to 5. So the only numbers that these 2 adjacent cells can take is from the ordered pair 2 and 3, the set 2 and 3. So basically, to fill the adjacent cell, we have 2 ways. The cell which is diagonally opposite to the first cell is already fixed by the condition of the sum of the diagonal elements. So the third cell can be filled in only one way. Similarly, the fourth cell is also fixed as per the diagonality condition. So the fourth cell can also be filled in one way. The fourth cell, which is this cell, can also be filled in only one way. So total ways is 4 for the first cell, 2 for the second cell, means 2 for the adjacent cells, and 1 for the diagonally opposite cell, and 1 for the diagonally opposite cell of the adjacent cell. So the answer is 8, which is the option D. So today we have solved question number 3 and 4 from the ISI Msqms paper of year 2016. We'll be solving the next questions in the subsequent videos. Till then, keep watching Synopsis classes videos for more solutions, and all the best for the upcoming exams. Thank you very much.